Science Space, Science Space. Come get your learning at the VSC Science Space. Come get your learning at the VSC Science Space.
Hi everyone. Before you start making any sort of solution, please be sure to check with all the different safety procedures associated with your lab. Make sure you know where the waste containers are. Make sure you know how to clean up spills. And again, talk to your instructor or teacher before doing any of this. Now, what we're going to do today is look at different ways of making solutions. And it all depends on the type of chemistry you're doing. If you're doing super precise analytical chemistry, then you're going to want to have super precise analytical style solutions. But if you're just doing something where you need a certain type of ion in solution, you don't have to be as precise or accurate with the job you're doing. So I'm going to show you both ways depending on the type of chemistry you are performing. Now, before we get going, let's look at some of the glassware we have available to us here. We have basically beakers. We have large beakers, we have small beakers, and we have Erlenmeyer flasks, and you can get larger ones of these as well. This one's only a 250 mils, but you can get smaller and larger ones. We also have graduated cylinders over here of various sizes, and we have volumetric flasks over here as well. And each one of these pieces of glassware serve a very specific purpose, and we'll go over that as we go through. Now, the other equipment I have here is obviously a balance, some chemicals, some deionized water. We have a scupula, weigh boat, and we actually have a magnetic stirrer here, and I'll show you how we can use that as well to help ease the pain of making certain solutions. The first thing we're going to do is make a 0.1 molar sodium bicarbonate solution. Now, what we're going to do, obviously, is get sodium bicarbonate, and this is a powder. Now, when you're looking at these bottles, make sure you make note of the formula weight, which is also known as molar mass, on the bottle. And in this case, the formula weight is 84.01. Make sure you write that down because you're going to be using that value for your calculations. Now, because I don't really care how accurate it is, I want to be, again, in the ballpark of 0.1, I'm fine using just regular glassware like this. In fact, what I'm going to do, because I only am going to make 200 milliliters of it, I'm going to use the 500 mil. If I try to use this one here, which is a 200 mil beaker, my volume is going to be right up to the top. So for stirring, moving around, for pouring, that's going to make it very difficult. So you have to really think about the glassware you're going to use before you start. You want to try to maybe have something about midway, and that will make it considerably easier for you to use. Okay, so there we go. Now the first thing you want to do is weigh out your material. Now, the scale we're using here only goes to 2 decimal places. So that's as far down as I can go. So what I'm going to do is use a weigh boat and put it down on here. And I'm just going to hit the tare button. What the tare button does is set it to 0. So what it's doing is it's already calculating the mass of the weigh boat. So I don't have to do all that hard subtraction later. I'm not good with the subtraction. So I'm going to hit tare. And now our scale is at 0. So anything that shows up on the scale is going to be the actual mass of the chemical. So grab your powder, open it up, and make sure the scupula or the utensil you're using is clean. If someone else has used it for another chemical, you're going to cross-contaminate. If you're unsure, it might be a good idea to maybe pour some of this into a clean beaker or something else. Make sure you don't put too much in there because anything that comes out of this bottle shouldn't go back into the bottle. Again, you're trying to watch out for contamination, and cross-contamination is a big issue in a lab, especially when there's a lot of people in your class. You don't want to take huge amounts or pour it out. I only need the 1.68 grams. So I'm going to start quite small. So that much there, I'm already almost at 1 gram. I'm at 0.97. 1.4, and you just have to keep tapping it. And sometimes you go over, but remember, because this one doesn't have to be super precise, even if I go over a little bit, which I have in this case, I'm actually at 1.78 grams now. Okay? I was aiming for 1.68. I'm not going to scrap this. I'm still going to use this because it's close enough for what I'm doing. Now, if you were concerned about it, all you would have to do is take your scupula, get a waste beaker, because again, I don't want to replace anything that's been out of the bottle in another container back into the container. So if I wanted to make it a little more accurate, I would just start taking little bits out. So now I'm at 1.74, 1.72, almost there. Now I'm actually at 1.69, which is really close to the 1.68 I was going for, and I'm happy with that. Now, the next thing I want to do is put it into the beaker so I could dissolve it. Now, just a little bit of terminology. When we're dealing with this, the thing that you're going to dissolve is called the solute, and the thing that you're dissolving it in is called the solvent. Most of the times, your solvent is going to be water. Again, deionized water. What I'm going to do is I'm going to pour that into here. Now, just be careful while you're doing that not to drop it anywhere else. With these weigh boats, sometimes it's good just to fold it in like this, and you almost make yourself a little bit of a funnel. Then go ahead and just pour it in. Now, again, I'm not trying to be super accurate with this, but there are a few little bits of the solute still stuck in this weigh boat. Now, what I'm going to do is just take my deionized water and give it a quick little rinse, and that way I'm getting all of it off. Now, that's super important when you're dealing with the more analytical chemistry where you have to be precise, but you could do it here as well. Now, one of the biggest mistakes that people will make while making a solution is now, while I have the solute down there, they'll pour the solvent in right to the top volume. Remember, I said I'm going to be making 200 milliliters of this. If I poured in 200 milliliters, there may be a problem with my volume after the fact. Certain salts in powder form take up less space as compared to when they're dissolved. When they dissolve, all of a sudden they take up more volume. And if my volume is right at 200 mils, and as that dissolves, all of a sudden my volume is above 200 mils, and now my accuracy is off. What you want to do is put in maybe half the volume first. So in this case, I'm going to put in about 100 milliliters. Now, just a little side note, again, whenever you have something that's not in its stock container, be sure to label it. This one's actually labeled deionized H2O. If it wasn't and someone else came by, they might just see a beaker of liquid. Is it concentrated acid? Hopefully not. Is it, a base? What is it? So it's very important to make sure you label things as you go so you can keep track of everything. Again, what I'm going to do is I'm going to put about half the volume. I'm going for a 200 milliliter solution, so I'm going to pour this to about 100 milliliters. And then all I'm going to do is dissolve it. So there's a few ways because, and again, because I used a larger beaker, my volume isn't right up to the top. I could actually grab it and do this and just give it a nice swirl. Now, some materials have a high solubility at room temperature and it won't take you long at all, whereas other materials will take a long time. In fact, certain solutions need to be gently heated in order for you to have it all dissolve. Now, make sure you don't do that unless the instructions tell you to do it, because it can be dangerous anytime you're using heat like that in chemicals. But some of them do require gentle heating just to push the solubility up a little bit. So I'm just going to keep doing this. Now, sometimes people get lazy. Okay, so what you can do is we have something here called a magnetic stir. Now, not everyone has the luxury of having a magnetic stir, but if you are waiting for something to dissolve, you can use one of these. What we have is just a small magnet, and you can get certain different types. This one's a little cross. This one is just a straight bar, and you just drop them in, and you turn it on. And instead of me sitting there swirling for hours, I'm going to let that do the work for me. Okay, now after doing that, we actually have all of the solute dissolved within the solvent. And again, it's really important to make sure all of it's done before you start adding extra volume. Now that it is completely dissolved, we're just going to top it up to the desired volume. And in this case, we're looking for 200 milliliters. So what I'm going to do, and again, because these aren't the most accurate in the world, it's okay for me just to eyeball it. So when you do that, you want to get down eye level the best you can, and then pour it in. Okay, so that's right at about 200 milliliters, and that's the final volume that I'm looking for. Now all I'm going to do is give it a good swirl. Again, this is why it's nice to have a larger beaker than your volume, because this would be very difficult to swirl if it was right up near the top. Other things you could use are glass stir sticks, just make sure they're clean. And give it a good swirl. And there you go, there is our 0.1 sodium bicarbonate solution. Now, remember what I said before, you don't want to leave a beaker just open. And actually, it'd probably be a good idea to put on a label before adding the things in it, but I didn't want to block the view. Now that I have this, I'm just going to put that on there, label it, and away you go. Now, if it's something that you're going to use right now, you could use it directly from this, or if you're going to store it, you're going to go get a storage container or something, some type, something with a top on it, whatever you need, and then save it for later. But again, make sure it's labeled well so everyone knows exactly what that solution is.